So I'm not going to discuss from the beginning, but I'm just going to show the concept flow. Okay, from where we have started with DFM method. Okay, we have started even to write the SPI class step 1 process. Under DFM method, there are 5 steps involved along with the iterations. Started with estimate the manufacturing cost. We have discussed input, output, manufacturing cost definition, what is unit manufacturing cost, then followed by the overall proposed design, how we are going to follow the 5-step method. Starting from estimate the manufacturing cost, reduce the cost of component, reduce the cost of assembly, reduce the cost of supporting productions. So today we are going to cover the step 2 process, and we are going to start with step 3, but not going to complete fully because it is little more information to be discussed. So step 2, what is step 2? Reduce the cost of component. Then we will move on to reduce the cost of assembly. Fine. And these are the things we have discussed. Under step 1 itself, understanding the unit manufacturing cost. It consists of three categories: component cost, assembly cost, overhead cost. Overall manufacturing cost, how to estimate, what are the things we have to keep in mind, considering with the general meaning, direct material cost, direct labor cost, and the manufacturing overhead. They have split it into component, assembly, overhead. Component are of 2 types: standard, custom. Custom means raw materials, processing, tooling. Assembly of 2 types: labor assembling or using some equipment tooling. We assemble parts. Overhead, very important 2 categories: supports cost and indirect allowance. Just wait. Then we have understood what is transportation cost. This also have to be considered when you are developing any product. Okay. Fixed cost and variable cost, the difference definition we have discussed. Then any product you move on to manufacturing unit, or you're going to create any parts to build the product, we have to list out the bill of materials used inside the product. So there is a little format to be followed. An example we have discussed. Then we have moved on with estimating the cost of standard components and custom components, 2 types. Estimating the cost of assembly we have discussed using some methodology which is already framed, and there is a separate software tools available. Any product, if you want to put some estimation regarding assembly of unit, assembly parts, assembly cost, okay, you can depend on this methodology. It's a particular system, involves as a tabular information system for keeping track of estimating assembly time for each parts. If you want to refer those informations to create your own products assembly cost, we can depend on this system. Assembly labor, in each and every industrialized nation it differs, so that information we have discussed. Estimating the overhead cost. Overhead cost includes cost drivers. What are all the cost drivers we have understood? Cost drivers include, like, first of all we have to understand what is the meaning of cost drivers. Something trigger a change in the cost of an activity, like direct labor hour workload, okay, worked, a number of customer contacts made, number of engineering changes order issued, number of machine hours used. These are all cost drivers. Examples.
Ma'am,
few students are waiting, just okay. Then after that, overhead rate. Whenever you are going to estimate any overhead cost for your product, if you depend on this ABC approach, it is convenient for us. So sometimes we will mishandle the overhead rate. Okay, we will not give an accurate estimations for the product. We have used the overhead charges. So to analyze those things, the problems is particularly addressed by activity-based costing. Okay. So what this particular approach does, there's a separate firm or company which frame for us to help to calculate or put an estimate for overhead cost. A firm utilizes more and different cost drivers. It has been analyzed with a lot of cost drivers occur for creating a product. Listing those things, how much cost drivers can be allowed for any product. So allocate all indirect costs to the associated cost drivers where they fit best. You can't avoid cost drivers in any product when you are developing. So for this type of cost drivers, how much rate you can fix. For example, you know what are all the cost drivers: direct labor, hour worked, number of customer contact made, number of engineering changes order issued. So this particular approach, they would have estimated those details and they have fixed some rate. Those informations can be used as a reference for our product in the case of estimating the overhead cost. These are the things. So today we'll move on to under DFM method, step 2 process. Our ultimate aim is to reduce the cost of component. When you are focusing on reducing the cost of components, automatically the estimation of manufacturing cost will be reduced. Then we can achieve the economic success of the product. So this is our ultimate aim when you are working under DSM team. So undergoing and reducing the cost of component, what are the things you have to keep in mind? You can't automatically reduce the component rate. Materials rate reduce panna mudiyadhu. If you are following some guidance or guidelines, or you can say design rules to guide the DFM, cost reduction decisions can be made. They are telling, first point they are telling us there are several strategies used for minimizing these costs. What cost of component, but there is some strategy followed in DFM method where when you follow those design rules, when you follow those guidelines, it used for us to reduce the component cost. Decisions can be made. So what are they? There are few subheadings under step 2 process. First one is understand the process constraints and cost drivers. What do you understand from the title? What do you understand from the title? First step 2 is reduce the cost of component. To reduce the cost of component, few subheadings you have to remember. Understand the process constraints and cost drivers. ஒரு ப்ராடக்ட்டை நம்ம கிரியேட் பண்ண போகிறோம், ஒரு லாட் ஆஃப் பார்ட்ஸ் வச்சு ஒரு ப்ராடக்ட்டை பில்ட் பண்ண போகிறோம்னா lot of components are needed, lot of raw materials are needed. Okay, so those components, whether these parts are necessary or not to build the product. Understand the process constraints. Constraints means some limitations, we say restrictions. Understand the process conditions, restrictions, limitations and cost drivers. இப்போ இந்த மாதிரி ஒரு காம்பனன்ட்ஸை நம்ம டிசைனுக்கு யூஸ் பண்ண போகிறோம், ஒரு ப்ராடக்ட் டிசைனுக்கு யூஸ் பண்ண போகிறோம்னா வெதர் இட் வில் காஸ்ட் சம் பிக் ப்ராசஸ் எக்யூப்மெண்ட் இன் த மேனுஃபேக்சரிங் யூனிட். அப்போ மேனுஃபேக்சரிங் யூனிட்ல எக்யூப்மெண்ட் டூல்ஸ் யூஸ் பண்ணால் ஆட்டோமேட்டிக்காக அந்த எக்யூப்மெண்ட் காஸ்ட்டை நம்ம பே பண்ண வேண்டியதாக இருக்கும். ஸோ யூ ஹாவ் டு அண்டர்ஸ்டாண்ட். ஒரு யூ ஜஸ்ட் இமேஜின் யூ ஆர் அ இண்டஸ்ட்ரியல் டிசைனர்ஸ், யூ ஆர் கோயிங் டு கிரியேட் அ பார்ட் டிசைன், யூ ஆர் ஆக்டிங் அஸ் அ பார்ட் டிசைனர். பார்ட் டிசைனர்னா ஒரு ப்ராடக்டை பில்ட் பண்ணுறதுக்கு என்னென்ன பார்ட்ஸ் தேவைப்படுமோ அதுக்கு ஒரு டிசைனிங்கை நீங்கள் தான் ஃப்ரேம் பண்ணுறீங்க. ஸோ ஒன்ஸ் யூ ஆர் அண்டர்ஸ்டாண்டிங் த லிமிடேஷன்ஸ் ஆஃப் அவர் மேனுஃபேக்சரிங் யூனிட் ஆர் ப்ரொடக்ஷன் யூனிட், ஸோ இந்த எக்யூப்மெண்ட்லாம் நம்ம யூட்டிலைஸ் பண்ணால் காஸ்ட் அதிகமாகும். அப்போ இந்த பார்ட் இதில் கொடுக்கறது நெசசரியா ஆர் நாட். Or some cost drivers also you have to keep in mind. You know, lot of cost drivers are being listed. Any engineering changeover happens or issue happens, it will affect a number of machine hours used when you give a particular part for the design of a product. Okay, try to understand some component parts may be costly simply because the designer did not understand the capability. If you are acting as an industrial designer, you imagine and in under that some members are there, part designers are there. They did not understand the capabilities, they did not understand the cost drivers which will occur at the end, or some limitations of the production process. Without understanding the process constraints or limitations, the designers are giving the part design for the product. That times we will face some what more cost put for a component to build the component. So first step is to reduce the cost of component. These issues may be involved, like some component parts may be costly simply because the designers did not understand the capability or they did not keep cost drivers in their mind. Some limitations of the production process, they put a part design. For example, a designer may specify a small internal corner radius. நல்லா புரிஞ்சுக்கோங்க, what is the meaning of small internal corner radius? Smartphone வச்சிருக்கீங்க கையில, there are lot of parts built inside the product. இப்ப டிசைனர் வந்து சரி இது இருந்தா நல்லா இருக்கும், like small internal corner radius if you give, it will be a good look, or it can be used for any component to be inbuilt. ஏதாவது ஒரு small part கொடுத்துட்டாரு டிசைனிங்ல. Small internal corner radius, maybe it is a particular part you consider on the machined parts. Without realizing, when this designer put a decision like this, give a part like this, that physically creates such a feature requires an expensive. கொடுத்த பார்ட்ஸ் என்னமோ சின்ன விஷயம் தான், ஆனா அந்த பார்ட்டை டிசைன் பண்றதுக்கு, ஃபேப்ரிகேட் பண்றது, இன்பில்ட் மோல்ட் பண்றதுக்கு there is a big operation to be performed. What is that? Electrode discharging machining. So அது என்னன்னு சும்மா ஒரு வியூ காமிக்கிறேன். Electrode discharge machining. அந்த particular hole போடுறதுக்கு ஒரு particular small internal, what is the point I have told you? Small internal corner radius, we are going to use a big operation, electrode discharging machining. So without understanding the process, the production process, the designer simply give this particular part, machined part, without realizing that physically creating such a feature will require an expensive electrode discharging machining. This machining. Okay. So what is electrical discharge machining process அப்படின்னு பார்த்தா, ஒரு பர்டிகுலர் ஹோல் இல்ல இன்டர்னல் ரேடியஸ் நீங்க ஒரு ப்ராடக்ட்டுக்கு கொடுக்கணும்னா you are using this particular machining process. Okay. Machining process. So electrical discharge machining is a non-traditional machining process based on removing material from a part. இமேஜின் பண்ணுங்க, உங்க ஸ்மார்ட் போன்ல இட் இஸ் ஃபுல்லி கவர்ட். ஒரு அந்த ஒரு மெட்டீரியலை அதுல இருந்து எடுத்தாதான் உங்களுக்கு அந்த இன்டர்னல் ரேடியஸ் பார்ட் கிடைக்கும். By means of a series of repeated electrical discharge between tools called as electrodes, and the part being machined in the presence of this dielectric fluid. So எவ்வளோ ஒரு பெரிய ப்ராசஸ் பாருங்க. The point they are telling here is you have to understand the process constraints. What are the limitations? Simply a designer should not give a particular part for the product, like simple internal corner radius. Why they give that particular specification? Because the designer that does not understand the capabilities, does not understand the cost drivers will come due to this giving the part. Constraints, conditions, limitations of the production process. For putting that particular small internal corner radius, a big expensive electrode discharging machining operations to be involved. So this is the first step. So a designer, what they have to do, may specify dimensions. They can put a part dimensions for a product. People wait பண்றாங்களா? Okay. With extensively tight tolerance, designers இதெல்லாம் fix பண்ணுவாங்க without understanding the difficulty of achieving such accuracy in productions. So sometimes these becomes costly. So ஒரு component cost எப்படி increase ஆகுதுன்னு அவங்க detailed informations கொடுக்குறாங்க. Without the well knowledge does not be known to the designers about, and does not understand the capabilities, cost drivers. They give a particular part. So sometimes this becomes costly. Part features are not even necessary. சில டைம் அது necessary இருக்காது for the component intended functions. ஒரு functionality or operation perform பண்றதுக்கு internal that particular parts is not necessary. Some designers give that. So they arise cost of lack of knowledge. It arises because of lack of knowledge by the designers. So it is often possible to redesign the part. So it avoid பண்றதுக்கு what we have to do, we have to reduce the component cost. So what they do, they redesign the part to achieve the same performance while avoiding the costly manufacturing steps. இப்ப designers in the particular parts unnecessary கொடுக்குறாங்கன்னா automatically this have to be involved for maintaining this expensive error-prone discharging machinery. So these can be avoided. So to do this, design engineer need to know what type of operations are difficult in the production. So இப்ப இந்த particular part நம்ம inbuild பண்ணா, ஒரு ப்ராடக்ட்டுக்கு inbuild பண்ணா, we have to face some expensive operations. But whether this is necessary or not, the designer have to know that knowledge. I think you are able to understand the flow. It's sweet. What happened? Hostelers. Okay, fine. So in some case, the conditions or restrictions of a process can be consciously communicated to the designers. So enna pannanum, that's why in each and every phase of the product life cycle, either in the planning or industrial designer have to communicate with the manufacturing unit members. There should be a proper communications or coordinations between them, because they frame the design rules. So they give the design rules to the designers. For example, capabilities of an automatic laser cutting machines அப்படின்னு design rules இருக்கு. இப்போ ஒரு பார்ட்டை அவங்க designers வந்து going to focus on creating a product. So they have to understand the design rules. இப்போ ஒரு internal small internal corner radius compulsory வேணும் ப்ராடக்ட்டுக்குன்னா they have to understand what type of operations to be performed. If you are going to depend on automatic laser cutting machine, so what is the capability of it? On basis of this design rules, the designers can consider the material type, material thickness, maximum part dimensions எவ்வளவு அவங்க ஃபிக்ஸ் பண்ணணும் when they put the part designing work, minimum slot with cutting accuracy. Only if they understand the design rules, then they can include that part for the product. So this is how they follow this step 2 process, understanding the process constraints and cost drivers. So when this is possible, when you are understanding the design rules, then this part designers can avoid extending the normal capability of a process and thereby avoid incurring, what do you mean by incurring? Suffering or occurring unusual high cost. High cost automatically reduce oil. For some process, the cost of producing a part is simply you need some mathematical functions to be known. So you are going to include any part for the product. The cost of producing that part, the designers have to understand the mathematical functions of some attributes of the parts. So what is that? So which would be occurring a cost drivers for the process? They put an estimation for it. So cost estimate for the redesigned intake manifold. What are they? As you all know, variable cost. What do you mean by variable cost? The material cost, direct material cost or piece rate labor, that are called as variable cost. Production supplies, so materials, manifold housing, manifold intake, running insert, molding, manifold housing, molding. இது வந்து லேபர் வச்சு நம்ம மோல்ட் பண்றாங்க. அந்த மாதிரி கேசஸ்ல வேரியபிள் காஸ்ட் லிஸ்ட் அவுட் பண்ணிருக்காங்க. So what type of unit here, how much cost has been estimated for it. Fixed cost, similarly, you are depending on some equipment, okay, tooling. So mold tooling again for manifold housing and intake, running insert for external or internal part building, component building. So what is the cost? Total direct cost, they add all the details. Overhead charges, you know what is overhead charges, like support cost or indirect allowance cost. It has been included here, 5.99. Total unit cost. First, before estimating the manufacturing cost, first you have to estimate the unit cost. How you will estimate the unit manufacturing cost for 6 months or 1 year? What is the input cost and output terms? Totally, the total variable cost and fixed cost and direct cost, you get 13.66. So our ultimate aim is to understand the process constraints and cost drivers. And understanding the design rules, the designers have to build the parts for the products. Example they have given. Redesign components. So again subheading under step 2 process. Try to understand the flow, students. Reduce the cost of component. First topic is understand the process constraints and cost drivers. Again subheading is redesign components to eliminate process stepping. When you are going to redesign the components, automatically you are going to reduce some component cost on basis of eliminating the processing step. What are all the processing steps? ஒரு component ஒரு product உள்ள build பண்றதுக்கு நிறைய processing steps இருக்கு manufacturing unitல. Molding, casting, fogging அதெல்லாம் நான் காமிக்கிறேன் உங்களுக்கு வியூவா. So what is that redesign component to eliminate the processing steps? You have to carefully scrutiny na enna artham? Examine or analyze the process design that may lead to suggestions whether it is necessary to redesign the component to focus to reduce the component cost that can result in simplification of the production process. நம்ம component ஓட informations reduce பண்ணாவே production process reduce பண்ணிடலாம். Complicated, இப்போ ஃபார் எக்ஸாம்பிள் நான் சொன்னேன் இல்லையா, ஒரு இதை வந்து நீங்க எலிமினேட் பண்ணாவே இந்த பர்டிகுலர் ஆப்ரேஷன்ஸ் எலிமினேட் பண்ணிடலாம். So that is why we focus on redesigning the components. So some processing steps may simply not be necessary. So reducing the number of steps in the part fabrication process generally result in reducing the cost. So what are all the processing steps which can be avoided? So may simply not be necessary. For example, a very simple example they have taken. இப்போ ஒரு அலுமினியம் பார்ட்ஸ் உங்க ப்ராடக்ட்டுக்கு யூஸ் பண்றீங்க, may not need to be painted because aluminum parts are used as an internal part for a product னு வெச்சுக்கோங்க. So அதுக்கு நீங்க பெயிண்ட் கொடுக்கணும் தேவையில்லை because user is not going to view that parts. Outlookல இருக்க போகுது. So especially if they will not be visible to the user of the product, so aluminum parts need not be painted. So you have to understand whether some process is needed or not. Aluminum parts க்கு பெயிண்ட் பண்ணனும்னா அந்த பெயிண்டிங்க்கு ஒரு செப்பரேட் ஆபரேஷன்ஸ் இருக்கு. ஒரு manufacturing யூனிட்டுக்கு ஒரு equipment இருக்கு, tools இருக்கு. So aluminum parts may not need to be painted. So especially it is not been found to the user, visible to the user of the product. So in some cases, several steps may be eliminated through substitution of an alternative process step. So this is how you avoid those processing steps. Another common example they have taken, there is a particular fabrication method used in the manufacturing unit called as net shape fabrication சொல்லுவாங்க. இது எல்லா ப்ராடக்ட்டுக்குமே யூஸ் பண்ற ப்ரொசீஜர் தான் ஸ்டூடெண்ட்ஸ். I will just show you what is net shape fabrications. It's another process in the manufacturing unit. Net shape manufacturing is a process that creates an object that is complete without needing finished machining or any other finished action. So how it look like this. You have to put a hole or something to inbuilt a part inside it. You have to assemble some parts. So இது ஒரு separate procedure. Near net shape manufacturing சொல்லுவாங்க. We'll go for the point. So this net shape process is one that produces a part with a final intended geometry in a single manufacturing step. ஒரே single manufacturing stepல you can create such a parts. அதான் சொல்றாங்க. So typical example includes how you are going to create those parts with a final intended geometry shape. In the case of molding, இப்போ molding machines இருக்கு, okay, equipments இருக்கு, machineries இருக்கு, okay, to make that parts. Another one, casting. Again, there is a machinery. Casting machines are widely used in various industries for manufacturing of products, parts, components, etc. So these machines facilitate the process in which the molded metals is posed under high pressure in the mold cavity. A specific pressure is applied on the mold cavity for perfect shaping of the product. So molding காக நிறைய எக்யூப்மெண்ட்ஸ் இருக்கு, இந்த கோல்டு இந்த மாதிரி நிறைய விஷயம். Fogging also a process machine, automated fogging press lines. அதோட capacity வந்து 400 to 2500 tons வந்து ஒவ்வொரு கம்பெனிஸ் யூஸ் பண்ணுவாங்க. accordingly the rate for அது பாருங்க எவ்வளவு இருக்கும் பாருங்க, 15 lakhs according to the ton capacity. If you are depending on large tons, 250 tons, 26 lakhs. So when you are making use of this equipment for creating any parts, automatically the equipment cost add ஆயிரும், component cost increase ஆயிரும். So இதெல்லாம் reduce பண்ணுவோம். இது மாதிரி lot of examples they have given. இதெல்லாம் processing steps. So our ultimate aim is whether this steps are needed or not. Some process steps may simply not be necessary. Extractions, அதே மாதிரி இது ஒரு machine process. Okay. So frequently the designers, when they give part designing for a product, are able to use one of the net shape process. ஏதாவது ஒரு process அவங்க include பண்ணுவாங்க. You can't avoid all the things. If suppose you are giving more parts, அப்போ automatically most of the processing steps have to be included. So அதை கொஞ்சம் avoid பண்ணலாம். The main thing is the designers are able to use one of the net shape process. இது எல்லாமே one of the net shape process to create a part that is very close to the final requirements. Near net shapes னு சொல்லுவாங்க. I'll show you what is a near net shape. I'll show you one example video also later. So may demand only minor additional process. உங்களுக்கு தேவை உள்ள additional process include பண்ணலாம், not all the things. Automatically when you are going to use all the things according to the component part design, the process differ, then it will be like using all the process, rate அதிகமாயிரும், component building rate அதிகமாயிரும், cost rate ஆயிரும். So drilling and tapping a hole, cutting to length, so everything we will use this processing steps. So our ultimate aim is when you are focusing on redesigning the component to eliminate some processing steps. So choose the appropriate economic scale for the part. Next subheading is choose the appropriate economic scale for the part process. ஏதாவது ஒரு பார்ட் ப்ராசஸை டிபெண்ட் பண்றீங்க, மோல்டிங்கா, ஃபேப்ரிகேட்டிங்கா, கேஸ்டிங்கா, எனிதிங், choose the appropriate economic scale, whether it will be good for our product designing. Economic scale fulfill பண்ணணும் இல்லையா, estimations போடணும். So economic of scales for a fabricated component occur for two basic reasons. ஒன்னு வந்து fixed cost. What do you mean by fixed cost? Equipment once நீங்க வாங்குறீங்கன்னா that is okay. Fixed cost, ஒரு work area set பண்றீங்க, or divided among more unit you are going to produce. So you are going to fix some equipment cost. Variable cost is raw materials becomes lower. Sometimes raw materials becomes lower because the firm can justify the use of larger and more efficient process and equipment. So நிறைய நீங்க vendors கிட்ட வாங்குறீங்க raw materials na, you can reduce those variable cost. Okay, you have to focus on these two things. Try to understand how you are going to choose the appropriate economic scale. You are going to fix some cost for fixed cost like equipment, or how much unit you are going to produce. You are going to buy the equipment or tooling work, or you are going to fix a work area for it. Again, variable cost becomes low because the firm can justify the use of large amount you are going to produce. So vendors kita, suppliers kita, ninga accordingly you can talk and reduce those variable costs also. For example, consider you are going to by an injection molded plastic part. Consider injection molding plastic part. The part may require a mold. இதை நீங்க கிரியேட் பண்றதுக்கு require a mold that cost. Mold means you need a equipment. It costs 50,000. If the firm produces 50,000 units of a part over the product lifetime, each part will have to be assumed. So ஒரு வாட்டி எக்யூப்மெண்ட் வாங்கி போட்டுட்டா போதும், எவ்வளவு யூனிட் நீங்க ப்ரொடியூஸ் பண்றீங்களோ அந்த எக்யூப்மெண்ட்டை யூஸ் பண்ணிக்க போறீங்க. So $1 of the cost of the mold happens. Suppose 100,000 units are produced. That time also each part would assume only 0.50 of the cost of mold. Process can be thought of a incurring. You can avoid fixed and variable costs accordingly. For example, இவ்வளவு யூனிட் ஃபிக்ஸ் பண்றீங்கன்னா அதுக்கு தகுந்த எக்யூப்மெண்ட் நீங்க யூஸ் பண்ண போறீங்க. ரா மெட்டீரியல்ஸ் வந்து இங்கேயே நீங்க ரெடியூஸ் பண்ணிடுவீங்க. ஸோ இட் கேன் பி அவாய்டிங் த சம் சிச்சுவேஷன்ஸ் when you're fixing the fixed cost and variable cost for your product part designing. So fixed costs are incurred. What do you mean by incurred? Suffering or occurring once per part type regardless of how many parts you are going to produce. So அதை வச்சு நீங்க ஃபிக்ஸ் பண்ணலாம். இப்போ எனக்கு வந்து ஒரு 10 யூனிட் 100 யூனிட்ஸ் தான் நாங்கள் ப்ரொடியூஸ் பண்றோம்னா you can fix the injection molding and start producing your parts. Variable costs also can be talked with the vendors each time a part is made. Okay, if you are going to produce large amount, you can lower the raw materials rate. More efficient process and equipment can be used according to the large quantity you are going to produce. So this is how you have to put an economic of scale estimation for the part process. You are not going to use all the part process. Molding equipment தான் யூஸ் பண்றீங்கன்னா அந்த ப்ராசஸ்க்கு எவ்வளவு எக்யூப்மெண்ட் எவ்வளவு பார்ட்ஸ் நீங்க பில்ட் பண்ண போறீங்க, எவ்வளவு ரா மெட்டீரியல்ஸ் தேவைப்படுது, அந்த எக்கனாமிக் ஸ்கேல நம்ம ஃபிக்ஸ் பண்ணிக்கலாம். லாஸ்ட் சப்ஹெடிங் ஸ்டாண்டர்டைஸ் காம்பனன்ட் அண்ட் ப்ராசஸ் அண்டர் ஸ்டெப் 2 ப்ராசஸ். வாட் இஸ் ஸ்டெப் 2? ரெடியூசிங் த காம்பனன்ட் காஸ்ட். அதுல ஸ்டாண்டர்டைஸ் காம்பனன்ட் நம்ம யூஸ் பண்ணும்போது again component cost reduce பண்ணலாம். What is you mean by standardized component and process? இப்போ HP கம்பெனிஸ் வந்து எல்லா ப்ராடக்ட்டுக்கும் ஒரு ஸ்டாண்டர்ட் காம்பனன்ட்ஸ் யூஸ் பண்ணுவாங்க. அதே மாதிரி GM கார்ஸ் வந்து எல்லா அதோட வெரைட்டி கார்ஸ்க்கும் ஸ்டாண்டர்ட் இன்டர்னல் பார்ட்ஸும் ஸ்டாண்டர்ட் எக்ஸ்டர்னல் பார்ட்ஸும் யூஸ் பண்ணுவாங்க. So like that, when you are fixing those standardized component, the principle of economic of scales also applies to the selection of components and process. So what type of component you are going to select for your product building? As a production volume of the component increases, இப்போ அதை வச்சு நீங்க ப்ரொடியூஸ் பண்ண போறீங்கன்னா the unit cost of the component will be reduced. ஏன்னா அதே standard component throughout your product variety you are going to use. So it will be reduced by the vendors, suppliers, and there will not be more loss. So for a given expected product volume, the benefit of subsequent high component volume can be achieved through the use of standard components. So whenever you depend on the standard components, you can focus on reducing the component parts. So standard components are those common to more than one product. அதுதான் HP companies நிறைய varieties காமிச்சாவும் standard components தான் throughout their variety products யூஸ் பண்ணுவாங்க. So this standardizations may occur within the product line of a single firm or may occur via outside suppliers. Same firms can produce those standard components or they can buy from the outside suppliers across the product line of the several firms. For example, best example they are given. So most of the GM cars நீங்க பார்த்தா அவங்க வந்து they will use 3.8 liters V6 engine as an internal standardization component. அதே மாதிரி 10 millimeter socket head cap screws வந்து across several auto manufacturers is example for external standardization. So இந்த standard components use பண்ணும்போது price rate will be less. Component வந்து component our ultimate aim is to reduce the component cost, right? Will be reduced. So component may also be standardized within the same model. So this is our ultimate aim. And last is acquire the black box component procurement. இது என்ன மேம் acquire the black box component procurement என்ன அர்த்தம்னா you have to gain procurement. You try to understand this, right? You have to follow some black box component procurement. Procurement is you have to gain a finding what is the solution. So what they have done is in step 2 process reducing the component cost. The component cost reduction strategy is being followed. What is that strategy? Japanese in auto industries, what they do, they follow this black box supply design. What do you mean by black box supply design is, இப்போ ஒரு part இல்ல component நீங்க build பண்றீங்கன்னா you are depending on some suppliers, you imagine. So it is suppliers' duties to reduce the cost of component and give the standard parts to build that product. So black box supply designs, under this approach what they did, the team provide a suppliers with only a black box description of the component. What does it mean by black box description of the component? Means like this. For a product என்னென்ன work பண்ணும், functionality என்ன, what is the input, what is the output. So ஒரு component அவங்க build பண்ணி கொடுக்கும்போது இந்த input கொடுத்தா இது output கொடுக்கணும். So it is supplier's duties to give a proper framework. Okay, for example, so window controller. So what is its real functionality? Ideally இருக்கும்போது எப்படி இருக்கணும், move up, move down. So இந்த மாதிரி இது functionality fulfill பண்ணணும். So when you are giving the overall black box functionality to the suppliers, so accordingly they will fix the parts and complete the input and output part of it. The point is, the DFM team provides a suppliers with only a black box description of the component. So the description will say what the component has to do. The window ordering la paatha, it have to move up, down, shut down, shut up, and mari. What the component has to do, they will give the description to the suppliers. Not how to achieve it. அதெல்லாம் இவங்க வந்து ப்ரொவைட் பண்ண மாட்டாங்க அந்த டிஸ்கிரிப்ஷன். ஸோ திஸ் கைண்ட் ஆஃப் ஸ்பெசிஃபிகேஷன் leaves the vendors with the widest possible latitude to design and select the component for the minimum cost. So as the work is given to the suppliers will always focus in wide possible latitude to design to fulfill the integrated of it, okay, to make the design more fixed one, not complicated one, and select the component according to it and make it the minimum cost. So an additional advantage of making use of this type of black box component procurement is an advantage. So that leaves the internal team of the responsible to the engineers and design the component. So suppliers who have those engineers and design work, they obviously suppliers or the main aim வந்து வெறும் parts மட்டும் supply பண்ணாம they are producing the functionality. Who are they? Japanese auto industries depend on those black box supply designs. So those designers fix the functionality, design the component which are needed to fulfill those products. So for the redesign intake manifold, for example PCV, what is PCV? Positive crane ventilation we saw, right? Wall assembly. The assemble பண்ணும்போது was designed by GMAC Rochester divisions, is one of the suppliers. The team just given the description of the component. What the suppliers done? Suppliers was given system level specifications. What is the input? What should be the output? What is the component has to do? They have given the suppliers the system level specifications and a complete responsible for the performance of this subsystem. So they are the responsibility persons to create. So when those responsibilities given to the suppliers, so they frame with the minimum cost. That's the point. ஏன்னா அவங்க எந்த அளவுக்கு ஒரு கம்பெனிக்கு அவங்க ஒரு மினிமம் காஸ்ட் காம்பனண்ட்டை யூஸ் பண்ணி அந்த சிஸ்டம் லெவல் ஸ்பெசிஃபிகேஷன்ஸ் யூஸ் பண்ணி ஒரு காம்பனண்ட் பில்ட் பண்றாங்களோ, இட் இஸ் அ குட் பெனிஃபிட் ஃபார் த சப்ளையர்ஸ். அப்போ நிறைய கம்பெனிஸ் அந்த சப்ளையர்ஸை டிபெண்ட் பண்ணுவாங்க. தேர் ஆர் லாட் ஆஃப் கம்பெனிஸ் லைக் தட் ஸ்டூடெண்ட்ஸ். அது மாதிரி நீங்கள் சும்மா நெட்டில் சர்ச் பண்ணாவே சப்ளையர்ஸ், வெண்டர்ஸ், அது மாதிரி நீங்கள் ஃபைண்ட் அவுட் பண்ணலாம். ஆல்ரெடி தாமஸ் ரிஜிஸ்டர் அப்படின்னு ஒன்று கொடுத்தேன் இல்லையா, வேர் யூ கேன் ஃபைண்ட் ஹூ ஆர் த suppliers, supply description of the component. You can just go for that particular net. உங்க ப்ராடக்ட் பில்ட் பண்ற சப்ளையர்ஸோட லிஸ்ட் எல்லாம் இருக்கும். ஓகே, இண்டஸ்ட்ரியல் சப்ளையர்ஸ்னு இருக்காங்க. ஸோ தீஸ் இண்டஸ்ட்ரியல் சப்ளையர்ஸ் வில் டூ தீஸ் ரோல்ஸ். ஸோ the DFM team members will give the system level specification to them and complete responsible for the performance of their subsystems. ஒரு காம்பனண்ட் என்ன மாதிரி இன்டர்னல் பார்ட்ஸ் பில்ட் பண்ணியிருக்கணும், என்ன ஃபங்க்ஷனாலிட்டி அவங்க கன்சிடர் பண்ணணும். ஸோ வாட் த காம்பனண்ட் ஹேஸ் டு டூ, ஆல் த டீடைல்ஸ் they will give it to them. So this will make the suppliers to put the component with the minimum cost. These are all the steps they have followed to reduce the cost of components. First, understand the process constraints and cost drivers. Again, redesign the component to eliminate some processing steps. You know, a lot of processing steps. You have to eliminate some processing steps. Choose the appropriate economic scales on the basis of fixed cost and variable cost for the part process. Standardized component is more useful to focus on reducing the component cost. So standardized component and process, how to identify those things. Adhere to black box component procurement, the methodology. Step 3. I hope you have understood step 2. Today itself you covered this topic, or else it will be vague when you start with after long gap. So step 3, reduce the cost of assembly. From the word itself you can understand the methodology you have to follow to focus on reducing the assembly cost. So design for assembly, we say DFA in short, is fairly well established subset for DFM method that includes minimizing the cost of assembly. So obviously you know what are the two types of assembly cost. One is labor cost and equipment or tooling assembly. So for most product, assembly contributes relatively small fractions of the total cost. Just wait, student. Just wait. Sorry, students. Okay. That's last only. So under step 3 process, we have to focus on reducing the cost of assembly. So again, here also we have to follow some guidelines. Few principles you have to follow, useful to guide the DFA designed for assembly decisions. So keep score. Keeping score na enna meaning na, you have already heard this terminology which we have said in step 1 process when we are discussing so when you are following this system, it involves a tabular information system for keeping track of estimated assembly times for each part. The same methodology is used for step 3 process. Yes. Boothroyd, Duhigg first advocate maintaining an ongoing estimate of cost of assembly. When you are this particular method is used to measure an index. That is, what is that index value? keeping score nave some calculation you have to follow. So that is the ratio of theoretical minimum assembly time. Try to understand, it's a ratio of theoretical minimum assembly time to an estimate of actual assembly time for the product. ஏன்னா it differs. இப்போ நம்ம ஒரு assembly time fix பண்ணுவோம் due to some delay or some theoretical minimum assembly time to it minimize some theoretical assembly time. So what is the ratio of theoretical minimum assembly time to an estimate of actual assembly time for the product? அசம்பிளினா என்ன, ஒரு பார்ட்டை ஒரு பார்ட்குள்ள இன்டெகிரேட் பண்ணுவோம், இல்ல ஜாயின் பண்ணுவோம் அசம்பிள் பண்றது. ஆக்சுவலா இவ்வளவு டைம் எடுத்துருக்கணும், but how much delay it happens or theoretical minimum assembly time எவ்வளவு ஆகுது. So this concept is useful in developing an inclusion for what drives the cost of assembly. So how to calculate that? To find the design for assembly index, there is a formula: theoretical minimum number of parts into 3 seconds only it should take. Okay, theoretical minimum number of parts into 3 seconds divided by estimate total assembly time. So to determine the theoretical, so இதை எப்படி find out பண்றது? You know the formula, DFI, the index, what is the formula? Theoretical minimum number of parts into 3 seconds divided by estimated total assembly time. So to find out the theoretical minimum number of parts, ask the following 3 questions. How to frame this? We'll go for that. First one, does the parts needed to move relative to the rest of the assembly? அதாவது part வந்து அடுத்த part குள்ள integrate பண்ணணுமா? Small motion that can be accompanied using complicants like elastic things or springs do not account. So அதெல்லாம் நம்ம eliminate பண்ணிடலாம். So does the part need to move relative to the rest of the assembly? So must the part be made of different materials? இப்போ ஒரு பார்ட்டுக்கு ஒரு ரா மெட்டீரியல்ஸ் யூஸ் பண்ணியிருக்கோம். அடுத்த பார்ட்டை நம்ம அசம்பிள் பண்றதுக்கு முன்னாடி must the part be made of different material from the rest of the assembly for the fundamental physical reasons. கொஞ்சம் அலுமினியம் foil கொடுக்கணும் ஒரு இன்டெகிரேட் பண்றதுக்கு முன்னாடி. So these are the questions we have to keep in mind before going for framing the theoretical minimum number of parts to be found out. Does the part have to be separated from the assembly for assembly access or replacement or repair? Some fault has been found out, again it has to be assembled or repaired. So இவ்வளவு questions நம்ம find out பண்ணிட்டு then only you can fix this theoretical minimum number of parts. Again 3 seconds we have mentioned in the formula, right? 3 seconds. What is the meaning of 3 seconds? Is the numerator reflects the theoretical minimum time required to handle or insert a part that is perfectly suited for assembly. ஒரு பார்ட் குள்ள ஃபேப்ரிகேட் பண்ணனும், அசெம்பிள் பண்ணனும், இன்டகிரேட் பண்ணனும்னா மேக்ஸிமம் insertion time is 3 seconds. So one can think of this average time sustainable over the whole work shift. According to this work shift, assembly cost should be framed. So required to assemble a small parts that is easy to grab, required no particular orientation, demand no special insertion effort. Such an operation is as fast as place a ball into a circular hole with adequate clearance. ஒரு ஹோல்குள்ள ஒரு பால் பிளேஸ் பண்ணா எப்படி இருக்கும், அந்த மாதிரி பெர்ஃபெக்ட்டா எந்த ஒரு டிலேவும் இல்லாம இருக்கிறது தான் at average time. 3 seconds it should complete the work without any delay. So one can think that the average time over a whole work shift, அப்போ ஒரு assembly time ஓட maximum எவ்வளவு இருக்கணும்னா requires to assemble a small part that is easy to grab, டக்குன்னு fix பண்ணணும், required no particular orientation, no deviations or demand no special insertion effort. Operations is so fast as placing a, நீங்க ஒரு சிம்பிள் அசம்பிளி ப்ராசஸ் பார்த்தாமே உங்களுக்கு புரியும் எந்த அளவுக்கு பெர்ஃபெக்ஷன்ஸ் இருக்கும். So you have to calculate on basis of this formula. DFA assembly. That's it. Last. So till this enough. Understand the formula, theoretical minimum time to see on net. DFA index. So the assembly process is an arrangement of machines, equipment, workers where the product to be assembled passes sequentially from one operation to another until complete. So it is also known as assembly line or production line. So DFM means for designers, design for manufacturing. Assembly refers to a set of practices or principles that seek to tailor the conceptual and design phase of product development to the given manufacturing method and in such way that ensure the easy and cost efficiency of productions. So when the assembly process is perfect with the formula frame, then there will be no delay. So assembly cost will not be more. And you have to raise those questions also. Easy of assembly in mind. So if the product contains few parts, it will take less time to assemble. அதுதான் நம்ம அல்டிமேட் எய்ம் வந்து ஒரு காம்பனண்ட்டை ரெடியூஸ் பண்ணணும். காம்பனண்ட் parts build used for product designing should be reduced. Should not be more complex. So when you are reducing those component costs, automatically assembly time also will be reduced. So if the product contains few parts, it will take less time to assemble, thereby reducing assembly cost. So till this you learn for today. And using Boothroyd Hub, you have to keep scrolling. Method. That's it. So how they are estimating those? Say, design the product, create an assembly matrix, part list with below part metrics, handling its size, weight, orientations, insertions, alignments. Okay, securing method. So for all things, this method will be useful. Assembly process. Okay, that's enough for today's session, students. Any doubt you have? Today itself revise step 2 and step 3 process started. Jay Surya, kindly send the absent list and
Yes, ma'am.
Thank you. You can leave the session.
Thank you, ma'am.
Thank you all.